Okay, magnesium. Describe in terms of electrons what happens when a magnesium atom reacts with chlorine atoms to produce magnesium chloride. Okay, so what happens when a magnesium atom, they tell you that there's only one magnesium atom, reacts with chlorine atoms, so they tell you there's multiple chlorine atoms to make magnesium chloride. Well, you need to know that magnesium chloride is MgCl2 and that there are actually two chlorine atoms that react with a single magnesium atom. You also need to remember for your exam that in MgCl2 magnesium has a 2+ charge on it, okay? And each chlorine has a -1 charge on it. But there are two chlorines, so therefore overall the charge is 0. And knowing that is going to help you answer this question. So, describe in terms of electrons what happens. Okay, it's 4 marks, so you've got to extract quite a lot out of this. So, how are we going to do that? Well, firstly, say that there's one magnesium atom and 2 chlorine atoms, okay? Now, it says describe in terms of electrons what's going on. The magnesium atom originally has 0 charge and it ends up with a +2 charge, and it's that therefore it must have lost 2 electrons because each electron has a -1 charge. So if 2 electrons have gone, it's left with a +2 charge. So say that the magnesium loses 2 electrons, okay? Don't write it shorthand the way I'm doing. Write out the word electrons in your answer, but I'll do it this way for speed. Okay, likewise, say that each chlorine gains 1 electron. Okay? Those 2 electrons that the magnesium has lost, they have to go somewhere, and each one of them goes onto one of the chlorine atoms. And that's why each chlorine becomes negatively charged. Okay? Right, what else can we say? You can say that in MgCl2, I'm going to draw it like this, Cl minus, Mg2 plus, Cl minus, okay? Say that it's an ionic compound. The bonds between the magnesium and the chlorine are ionic, they're not covalent. I didn't draw a single line which would be a covalent bond. This is an ionic compound. What else can you say? Oh yes, you do need to say this. Say that in the MgCl2, magnesium chloride, both the magnesium and the chlorine have full outer shells. You can also say, if you like, that they have a noble gas electronic structure. The magnesium, having lost 2 electrons, has 8 electrons in its outer shell, which is the noble gas configuration. Same as the chlorine. Each of the 2 chlorines now has, because of this, the way the electrons have arranged themselves, now has 8 electrons in its outer shell. Okay, all that will get you the 4 marks. Right, next question. Explain why magnesium chloride must be molten or dissolved in water to be electrolyzed. 2 marks. Okay, so magnesium chloride, this stuff again. Why must it be molten in order to carry a charge? Well, in its molten form, the Mg2 plus ion is free to flow, and the same with each of the chlorine ions, and that's the reason. When it's molten, the magnesium ions can flow around, move freely and carry charge, say all of that, and the same with the chlorine ions. And it's the same when it's dissolved in water. When it's pure magnesium chloride, it has to be molten in order for the ions to be free. If you dissolve it in water, it doesn't have to be really hot. When it's dissolved in water, these ions dissociate and they're also free to flow and carry charge in water. So, to get the 2 marks, you need to say that in the molten form or the dissolved in water, the ions are free to flow and carry charge. Say that the magnesium ion flows towards the negative electrode because positive attracts negative, and say that the chlorine ion flows towards the positive electrode. There you go. That will get you the marks. Okay. Explain how magnesium is produced at the negative electrode. Right, so, and this is for experiment 1, which is the molten one. Okay, so we've got some power supply here, negative electrode here, positive here. Now, in here, we've just got pure magnesium chloride. So you've got Mg2 plus floating around and Cl minus floating around. Nothing else. It's molten. And it wants to know how magnesium is produced here, the negative electrode. Well, 3 marks. Okay, so you've got to be thorough. First thing to say is that the magnesium flows towards the negative electrode. Okay, magnesium is positive, negative electrode is negative, and that's why it's attracted toward it. Next, you need to say that the Mg2 plus gains 2 electrons. So it becomes pure magnesium. And that's it. If you like, for the third point, you can say when the magnesium has 0 charge, it's pure magnesium. But that's kind of, you've already said that here. Okay, that's it. That will get you the 3 marks. Good. Right, in the other experiment, okay, the one where we still have a negative electrode here, positive electrode here, but this time it's in water. So we've got Mg2 plus, Cl minus, okay? But it's also in water. Now water dissociates into H plus and OH minus, okay? In a cup of water, there's a lot of H2O molecules, obviously, but they're constantly dissociating and reassociating. So you've got H2O, okay, it's constantly dissociating. One of the hydrogens is dissociating from the OH. So it's dissociating to H plus and OH minus. And I've drawn this double arrow because it reassociates back to H2O. What I'm trying to say is that in an aqueous solution in water, there are always going to be some H plus ions, and that's really important here. Because, what was the question asking? Right, you have to name the gas that forms at the negative electrode, okay? There's some gas forming here, okay? Bubbling up. What is that gas? Well, it's hydrogen, okay? So that gets you the 1 mark of this question. Now the next question, okay, I'll write that there. It's H2, hydrogen gas. The next question says, suggest why magnesium is not produced at the negative electrode. Right. So you could be forgiven for thinking that, like in the molten case, magnesium should be produced at this electrode. However, the difference is the presence of these hydrogen ions. What happens is that the electrons on the negative electrode jump onto the hydrogen instead of the magnesium. They have a choice. They're both positively charged, so the electrons can go there or there. And they choose the hydrogen because magnesium is more reactive than hydrogen in the reactivity series. And when an element is more reactive than another one, it wants to stay as an ion more. Think of it that way, okay? That's how to remember it. Magnesium is more reactive than hydrogen, and therefore it wants to remain as the 2+ ion more than hydrogen wants to remain as the H+ ion. Therefore the electrons go onto the hydrogen, and therefore it forms hydrogen molecule, and which is a gas. Okay, so to fully understand this, you need to know the reactivity series. So I won't go into the reactivity series in this video, but do learn the reactivity series, and I suggest memorizing a mnemonic to help you. So you should know that magnesium is more reactive than hydrogen to get this question and fully understand it. Good. Okay. Right, next question. Complete and balance the half equation at the negative electrode. Right, so let's do it up here. We have something, Cl minus, goes to Cl2 plus something. Okay, this is the half equation at the positive electrode. So, half equations means electrons, okay? So what have we got? Well, there's Cl2 here. Little 2 means there are 2 Cls, right? So there must be 2 Cls on the left. What goes in must come out, okay? Cl2 is just chlorine, the molecule, so Cl, Cl. Okay. Now, what goes in must come out. We deal with the minuses now. It's where the electrons comes in. Each Cl has 1 minus on it, and there's 2 of them. So we've got a total charge of 2 minus on the left going in. So we must have 2 minus coming out. Cl2 is neutral, there's no charge on that. So it must be 2 electrons coming out. And that's it. That's the half equation. 2 Cl minuses go in, it makes Cl2 plus 2 electrons. Okay, last question. Explain why metals can be bent and shaped. Okay, well, nothing wrong with a little diagram in these answers. You've probably been made to draw the structure of a pure metal which is this. These are all meant to be the same size. A pure metal, the atoms are lined up like this. Okay, they all have a positive charge. Have you been taught to draw it like this? With the electrons floating around the so-called electron sea, and they're free to move in between the ions or the atoms. The atoms are ions. Okay, so that's the sort of classic drawing of the structure of a pure metal. Right, we have to explain why this structure can be bent and shaped. Well, say that pure metals are made of layers of atoms or ions. Either is okay. I think I prefer atoms, but it's up to you. Okay, this is a 2-mark question. For the 2nd mark, you need to say that these layers can slide over one another.